Hi students, let us now take a look at 2013 O-Level Paper 2 question 3. Alright, so this question for the first part is regarding remainder and factor theorem, and for the second part is regarding cubic equations. Okay, so let's start by reading the question. Okay, so the function fx, which is given by x cubed plus ax plus b, where a and b are constants, is exactly divisible by x plus 3. Okay, so the moment you see that the word exactly divisible by x plus 3 means when fx is divided by x plus 3, the remainder will be 0. Okay, so this will actually enable us to find the first equation. Okay, then for the second equation, we are told that fx leaves a remainder of 56 when divided by x minus 4. Okay, so this means that f4 is going to be equals to 56. Okay, and this will allow us to form our two equations. Okay, and how do I know I will need to form two equations? Because if you look at the fx function, there are two unknowns, a and b, inside the function. Okay, so whenever you see two unknowns, the first thing you must think about is that you will need to solve simultaneous equation in order to find the two unknowns. Okay, and in order to do that, you will need two equations. Okay, so let's go ahead and let us form our two equations. Okay, so let's write a statement. So since fx is exactly divisible by x plus 3, okay, let me draw a line here. Okay, we can say that f minus 3 is equals to 0. Okay, so we are going to use this to form our first equation. So f minus 3, all we need to do is replace all the x in fx, right, with negative 3. So you have negative 3 cubed plus a minus 3 plus b equals to 0. Okay, so let's simplify this. Okay, so usually what I like to do is I like to bring all the numbers to the right side. Okay, and leave the letters on the left side. Okay, then I call this equation 1. Right? Okay, so now let's form our second equation. In order to solve two unknowns, we need two equations. So fx leaves a remainder of 56 when divided by x minus 4. So this means that f4 is equals to 56. Right? So we're going to replace the x in fx with 4. So 4 cubed plus a times 4 plus b equals to 56. Okay, so 4 cubed is 64 plus 4a plus b equals to 56. Okay, same thing, I'm going to bring the numbers to the right side. Okay, so 56 minus 64 will give me negative 8, and this will be my equation 2. Okay, so you see that equation 1 has a b, a plus b. Equation 2 also has a plus b. So this means that we can subtract both equations, okay, or subtract equation 2 from equation 1. And that will allow us to get rid of b. Okay, so over here we are using the elimination method. Okay, so equation 1 minus equation 2. Okay, so you will have minus 3a plus b. Okay, so left side minus left side of the equation, minus 4a plus b equals to 27. The right side minus right side, minus minus 8. Okay, so over here be careful, minus minus 8, right? Okay, so from the left side, the b will be gone. Actually, that's the main purpose, right, to get rid of the b. So minus 3a minus 4a negative 7a will be equals to 35. Okay, so a is going to be negative 5. Okay, so we have found the value of a already. Okay, so all we need to do is sub the a, right? Negative 5 inside equation, maybe let's do equation 2. Okay, so substitute a equals to negative 5 into equation 2. Okay, because the numbers are smaller in equation 2. So 4 times minus 5 plus b equals to negative 8. So you have negative 20 plus b equals to negative 8. So b should be equals to 12. Okay, so just like this, we have solved for a and b. Okay, so remember, whenever you see two unknowns, always think of forming two equations. Okay, and then solve those two equations simultaneously to find the two unknowns, right? Okay, let's move on to the part 2 of the question. Okay, determine showing all necessary workings, the number of real roots of the equation fx equals to 0. Okay, so whenever you want to solve fx equals to 0, you will first need to think about factorizing fx. Okay, and over here, fx is a cubic equation. Okay, so now we will need to think about how to solve a cubic equation. Okay, but first let's replace the a and b with the values that we have found in part 1. So a is -5, b is 12, so fx will be, okay, fx will be x cubed. Okay, a is -5, right? So -5x plus 12. Okay, so this is the cubic equation. Okay, to solve, to factorize a cubic equation, you will need to know one of its factors. And we already know that because fx is exactly divisible by x plus 3. So x plus 3 is a factor of fx. So x plus 3 is a factor, so we will put x plus 3 here. Okay, so since this is a cubic equation, down here is degree 1, right? Degree 1. Okay, degree 1. Okay, degree 1 must times degree 2, okay, to give us degree 3, okay, the cubic equation. So over here is a quadratic equation, okay. Okay, so to find the quadratic equation, a quadratic expression, okay, or quadratic function. Okay, to find the quadratic function over here inside this blank bracket, right, it's not difficult. We can actually use observation method to find the first term, the x squared term, and the constant term behind. So ask yourself, x times what will give you x cubed. Okay, so it will become obvious that it's going to be x squared. Okay, the center term we don't know yet. Okay, so we always call it bx. Okay, so later on we will find b. Okay, the last term also very easy to find. 3 times what will give you positive 12. Okay, so you should be able to realize that it's plus 4, right? Okay, so from here, we just need to find b, and then we can go on and then fully factorize this whole thing. Okay. Okay, so to find b, usually what we'll do is we'll equate coefficient of either x squared or equate coefficients of x. Okay, so maybe we can equate coefficient of x squared for this question and see what happens. Okay, so equating coefficient of x squared. Okay, so some of you are wondering, inside this fx cubic polynomial, right, there's no x squared term. Okay, there's no x squared term. So what is the coefficient of x squared? Okay, so if there's no x squared term, it means that the coefficient of x squared is 0. That means over here, there is a plus 0x squared. But because it's 0 times x squared, so it's 0. That's why we don't write over here. Okay, so we can still compare coefficient of x squared. In fact, it's easier because now the left side will be 0. Okay, then now we need to go and find the x squared term inside this multiplication, okay, this product. Okay, so which one times which one will give you x squared? Okay, so x times bx will give you x squared, right? Bx squared. Okay, and then over here, 3 times this x squared will give you 3x squared. Okay, so in other words, the coefficient will be b plus 3. Okay, b plus 3, the coefficient of x squared. So b plus 3. Okay, so if 0 equals to b plus 3, that means b will be equals to -3. Okay. Okay, so now that we have found b, we can actually go on and fully factorize fx if we are able to. So we have x plus 3 here, x squared minus 3x plus 4, right? Okay, so if you think about it, you try to factorize this, you realize that this one cannot be factorized. Okay, cannot be factorized. Okay, if cannot be factorized, then just leave it. Okay, there's nothing you can do about it. Okay, but remember, they want us to find out the number of real roots of the equation fx equals to 0. Okay, that means they want us to solve this, right? And then they're asking us how many real roots will there be. Okay, so since we have fully factorized fx already, we can then write this down. Okay, so if x plus 3 times x squared minus 3x plus 4 is equal to 0, it means that either x plus 3 equals to 0, and this will give us x equals to -3, So we have at least one real root already, one real root already, or x squared minus 3x plus 4 equals to 0. Okay, so now we just need to see whether this one has any real roots or not. Okay, so over here we have a quadratic equation. If we want to see whether it has any real roots or not, what we can do is we can find out, or rather calculate out what is the discriminant, b squared minus 4ac. Okay, b squared minus 4ac is greater than 0, then it has real and distinct roots. Okay, b squared minus 4ac is 0, it has real and equal roots. But if it's b squared minus 4ac less than 0, then it will have no real roots. Okay, then there will only be one real root, which is x equals to minus 3. Okay, so let's go ahead and test the b squared minus 4ac. Okay, so b is minus 3, okay, c is 4, and a is 1 over here. Okay, a is the coefficient x squared. So minus 3 squared minus 4 times 1 times 4. Okay, so you have 9 minus 16. So 9 minus 16 is negative 7. So b squared minus 4ac less than 0. It means that this one has no real roots. Okay, this quadratic on the right side has no real roots. Okay, so let's conclude with a statement. So since b squared minus 4ac less than 0, okay, x squared minus 3x plus 4, the quadratic equation on the right has no real roots. There's no real roots. Okay, so this whole cubic equation fx equals to 0 only has one real root. Okay, so fx equal to 0 only has one real root. Okay, which is x equals to negative 3. Okay, so the answer is there's only one real root, right? Okay, so this is how you solve a question like this. Not too difficult. Okay, actually a rather typical question, right?